Welcome back. In the last lecture session, we have discussed about the networking, advanced topic, and under advanced topics, networking, and it was unit number 8. And in this lecture session, I will start unit number 6, which is simple algorithms and data structures, one of the important topics in computer science. In fact, in computer science and engineering and information science and engineering, data structures and algorithms are two separate subjects. They will study it as an independent course, whereas we will give just a tip of an iceberg as a single unit in this Python programming subject. It is unit number 6, simple algorithms and data structures. What is a data structure? A data structure is the collection and organization of data so that we can perform operation easily on those data. Example of data structure is a stack, a queue, etc. where we have data, lot of raw data, and if that data is to be organized in a very systematic, specific way, it is called as logical or mathematical organization of data so that we can perform operations on those data. For example, your USN. According to your USN, your marks can be assigned. According to the marks, a grade can be allotted. Finally, CGPA, SGPA can be computed. That is the organization of data. Without giving USN to a student, simply by taking a student name, we cannot organize the data because there may be same names. There may be redundancy. So that is called organization of data, and this organization of logical or mathematical form of a data is called data structure. Then what is algorithm? Algorithms are the steps to be followed to perform a specific task on these data. For example, I want to arrange numbers. I want to arrange numbers in ascending order. What are the steps to be followed in different types of algorithms that we have to use for arranging numbers either in ascending order or descending order? They are called algorithms. So how to bring the least number to the first place for an ascending order, or how to bring the largest number to the first place in the descending order, that tells about the algorithms. In fact, algorithms are the steps to be followed in performing a task on the data, whereas organization of data is called data structure. Here in unit number 6, we will not study all algorithms and all data structures. Only some of the important algorithms will be discussed. In fact, so they are searching algorithms, sorting algorithms, and hash tables. In searching algorithms, we have to study linear search and binary search, whereas in sorting algorithms, already in microprocessor theory and microprocessor lab, you have studied bubble sort. Here in this course, we will study selection sort and merge sort. Then hash table at the end. We will study the concepts and what are the steps to be followed, what is the type of data structure, and we will write Python program to perform those operations, to implement an algorithm. Let me see one by one. First one, I will discuss about search algorithm. The first one is linear search algorithm. A linear search algorithm is one where we have to find out whether a key is present. Key means a element which is to be searched, whether that key element is present in the given list or not. If that element is present, you display it, yes, it is successful. Otherwise, you display it, no, it is not present in the given list. It is a very simple thing. A linear search algorithm is one, and it is the simplest form of search algorithm. Let me explain what are the steps to be followed in linear search algorithm. Number one, input the search element, the number or a name, whatever I want. Whether the data I want or the element I want to search is present or not, to determine that one, first I have to input the data. So input the data either through a keyboard or directly you type it as part of the program. And second step is compare the search element with the first element in the list. In the list we have so many elements. It is stored in the form of a list. As you know, list is mutable. So you first check whether the search element is present in the very first position at 0th index by comparing the search element with the first element. If both are matched, that means if the search element is present in the very first location, then display given element is present and come out of the function. So we have to write a function, or we can write within the main program only. It is better always to write a function, a method which is written separately. So if the first element is if both are matched, if the comparison is successful, then display given element is present. If both elements are not matched, if the first element is not matched with the search element, then compare search element with the next element in the list. So go to the second element in the list, again compare. So then fourth element, fifth element, in the same way you proceed further. That means repeat steps 3 and 4. That means check whether they are equal or not. If it is equal, so then display, otherwise you go to the next element. Repeat steps 3 and 4 until search element is compared with last element in the list. So till the list is over, you go on comparing with the individual elements of the list. Then the last step, if the search element in the list, the last element, if last element in the list also does not match, then display given element is not present and terminate the function. So the operation here is, after comparing all elements, you come to the last element. Even the last element does not match with the search element, then display given element is not present and terminate the function. So I have written two programs here for linear search. One program I call as linear search 1.py, and the second one linear search 2.py. Okay, so the difference between these two is, the first one is it searches a list even though the list is not arranged. You see here 9, 51, 63, etc. up to 300 and 380 it is arranged. Afterwards 25 is inserted here. 25 is present of course. So this is an unordered list. The list is not arranged in an order. So linear search 1 program detects yes 25 is present. Whereas in linear search 2 it expects the list to be in order, in say ascending order. Since 25 is present at the end, in fact its position is the second one. After 9, 25 should present. The second searching program, linear search 2.py, says this element 25 is not present. So let us run these two programs, edit these two programs first by using Anaconda editor. Then let us see by running the program. So this is my first program, linear search 1.py. So I have written a method here, a function here. So which is away from the main program. This is my main program. So I have a list as I have specified in the explanation. The list, the elements in the list are 9, 51, 63, 99, 109, 190, 201, 380 and 25. 1, 2, 3, 4, 5, 6, 7, 8, 9. Totally there are 9 elements starting from 9 up to 25. Next, if search within the if else statement, you call the function search L comma 380 equal to true. That means to the search program, to the search method, I have to supply two elements, two parameters. First parameter is the list itself, where I have to check whether it is present or not. And the second input, second parameter here is the search element. Then these are assigned to L and E of the search here. This is the definition of my search function. So L is assigned to L and 380 is assigned to E. E is the search element. I use a for loop. For will go I in range. I starts from 0 till it reaches the length of L. What is the length of L? It is the number of elements 1, 2, 3, 4, 5, 6, 7, 8, 9. L equal to 9. So F in the for loop, I will take value from 0 up to 9 minus 1, because the length minus 1. For loop will go till the last element minus 1. You know that one. And it iterates starting from index 0, 1, 2, 3 up to the last. The index of the ninth element is 8, of course. Now, after the first for loop, it enters into an if statement. If L of ith element in the list L, which is the I is equal to 0, L of 0 equal to E, which is L of 0. L of 0 equals 9. That means I am comparing the first element in the list with the search element. Search element is 380. What is the first element in the list? It is 9. Is 9 equal to 380? No. If it is not, it will go back to the for loop. You see here, my for loop starts from here up to this one. The last return false is not part of the for loop. You see the indentation. The if statement is only between these two. Only return true is corresponding to the indentation of if statement. Whereas for loop, we have these two statements. First, we check by using an if statement, then we return if it is successful. Otherwise, it will go back and I will be incremented to 1 in the for loop. Okay, now I equal to 1. L of 1 is equal to 51. Is 51 equal to search element 380? No. So it will go back. This for loop will be repeated. It goes to searching for the next element 63, 99, 109, 190, 201, then 380. Now 380 is equal to the 380 search element and return true. So now the element in the ith position here 380 is equal to the search element. Since this is a Boolean operation, double equals, it will return a true. So it will come to the main program. If search is equal to true, it prints given element is present in the list. Otherwise, it says given element is not present in the list. Let me run this program. You see here, given element is present in the list. 380 is present in the list. Now, I will make a simple alteration here. Instead of 380, I will give some number, say 58. Is 58 present here? No, 58 is not present here. Let me run this program and see how it works. You see here, the result displayed here is given element is not present in the list. It searches all element is in the list. So my key search element is 58. It says it is not present. So first element 380 is present, second one not present. Now if I give 25 here, so 25 is a number which is at the end. It is not it's an unarranged list. Let me see, will it search and gives me the result. See the result here, given element is present in the list. 25 is the given element. It says yes, given element is present in the list. I have written another search program, linear search 2, where if I give 25 here, it will say it is not present. It expects only an arranged list, unlike this program that we will see in the next lecture session. Thank you.